All right, so you guys remember a while back we talked about that unit circle, or it may not have been that far back. At least it was from me. Jeez. So on your unit circle, you've got the angle created right here, depending on where you are on the unit circle. And we said that the x value represents the cosine of that angle, and the y value represents the sine of that angle. Anyway, this thing continues to loop round and round and round. Well, we're going to be talking about trigonometric equations here in a little bit, but there's a couple of different ways to think about them. And I want to plant the seed in the back of your mind for what the graphs of sine and cosine look like. It's not going to be that big of a deal right now. On your homework, you are going to have to graph these on Desmos and kind of look for how many times the graphs intersect with something. But I want to show you first off where the graphs come from. All right. So I'm going to click right here for the sine animation. Now what this is going to do is as I move that point around again, all right, as this point moves around, the green graph right here is going to be the sine function. It's keeping track of the y value at that point as it moves around. All right. So here, the y value is at a 1, or it's supposed to be at a 1. And this graph it has a y value of 1 there. Let me go ahead and just turn that on. And see it makes this nice little curve. They actually call that a sinusoidal curve. And then once it reaches right here, a full lap around the circle, this is going to be like the main part of the graph of the sine function that you kind of need to know. So we went from 0 all the way around to 2 pi. And so the graph of the green part, the actual graph that you want to actually keep in the back of your mind, is from 0 to 2 pi. This little curve right there, that's the graph of sine from 0 to 2 pi. All right. If I continue to let it do its thing, you see it continues to keep tracing out values and continues to keep tracing out values. And right here, it resets, but technically it continues to go on further and further down. All right, that was the graph of sine. Let's pause this thing, and we'll look at the graph of cosine. So cosine does the same thing, but instead of starting dead center, it starts up here. It starts up here at the top. It actually starts at 1 and then starts making the little dip down. All right. And if we look at it again from 0 to 2 pi, let me try to make that as close as I can. 6.2 maybe? 2. That's about as close as I can get. I was trying to get it to 2 pi. But it makes this almost like a U shape. All right. But it still has the same features going on. So there's your sine and your cosine graph. What we're going to be doing on the homework is I'm going to give you an equation like sine of x is equal to 1, an equation like that. And we're going to use the graph on Desmos to solve it. So what we do is we graph sine of x. Right, you see how it kind of goes on forever. Now, right here, if you can see that, what I want you to look for is from a certain interval. So in these first couple, let's do it from 0 to 2 pi. You don't have to actually do this, 0 to 2 pi. I'm only looking at that little interval, though. That's what we're looking at. All right. So just that range of x values. And then we're also going to graph the right side of the equation, which was 1. So if I graph that, so we're only looking at where the two intersect on that interval. So from 0 to 2 pi, they only intersect at that one spot. So this would only have one solution, right? And that is pi over 2. If we were graphing, let's say we were trying to find sine of x is equal to square root of 2 over 2, like that. So this one, if we're looking at it from 0 to 2 pi again, all right, there's our 2 pi. From 0 to 2 pi, they only intersect twice. All right, once at pi over 4 and the other at 3 pi over 4. Let's look at cosine this time. All right, let's say we had cosine of x, and we'll say it's equal to 1/2. So what I'm going to do here, ooh, that looks ugly. Let me just graph. That's the equation we're going to solve, but we have to graph them separately. So cosine of x is right there, and then 1/2's right here. So if we were looking at that same interval from 0 to 2 pi, all right, there's 2 pi, you can see it crosses once there and once there. But I don't always ask about the interval 0 to 2 pi. Sometimes it's helpful, it will be later anyway, to look at the graph from a different interval. Let's say we looked at it from negative pi, -3 and some change. So negative pi to positive pi. So we're looking at that interval this time. Here, show you what I mean again. Negative pi to pi, like that. So we're only looking at that little interval of the piece. All right, and again, it only crosses twice, once right there, and the other at pi over 3. But here's one. So these have all been kind of regular looking, I would say simple trig equations. If I change it, instead of having cosine of x, let's say I had cosine of 3x, notice something very different happens here. All right, it just it kind of speeds up the process. It oscillates more quickly, and we will talk more about the graphs of these later. But I just want to give you kind of an idea for how many solutions the actual equation will have. So if I was to look at this, cosine of 3x is equal to 1/2. But if I only wanted to do it from negative pi to positive pi, which is negative 3.14 to positive 3.14, well, it's kind of busy. So from there to there, we're just counting the intersections. So 1, 2, 3, 4, 5, 6, and then it stops right there. So there would be 6 solutions from negative pi to positive pi. And again, if you want to clean up the picture, you can do this, what I'm doing here, x and then pi. So it's only graphing it from negative pi to positive pi. That might be simpler if you can kind of see what's going on there. But in general, these trig equations, if we don't care about solutions between some window to some other window, you can see as it goes on forever, they actually intersect an infinite number of times. All of these equations do that, right? Whether it was just regular cosine of x, right, it still intersects because cosine goes on forever. It'll have an infinite number of solutions. Each of these equations will. All right, so kind of keep that somewhere in the back of your mind. This is what the graph of cosine looks like, and this is what the graph of sine looks like. They're going to be important later, but as far as the homework goes, you're just kind of counting on a certain interval. You're counting how many times the graph intersects with another given function. Okay.